Let's practice with some linear modeling. The Happy Widget Company has a fixed cost of $1,500 each day to run their factory and a variable cost of $125 for each widget they produce. So here in this problem, we are talking about the cost to run this company. So create a linear model. Y equals, okay, when I think about my slope is what happens over and over and over. It's recurring. Well, I am paying $125 for each widget. So that for each implies a reoccurring cost, right? It costs less to only produce maybe one widget versus 10,000 widgets, right? Makes sense. Then I have a fixed cost of $1,500, right? For maybe employee salaries, this is each day, lighting, water, other things, right? Okay, so what do X and Y represent? Well, X is the number of widgets, and Y is total cost to run the factory, right? That's what these things are dealing with. So, using this model, we can play. How much does it cost to produce 300 widgets? Well, that means X is 300. So Y equals 1.25X plus 1,500. So I'm going to plug that 300 in for X. 1.25 times 300 plus 1,500. I multiply first, and I get 375 plus 1,500. So to produce 300 widgets, it's going to cost the company $1,875 that day. And let's say that they say, you know what, today let's only spend $2,040. Well, that's the total cost. So if I have Y equals 1.25X plus 1,500, that total cost is going to go in for Y. So 2,040 equals 1.25X plus 1,500. Divide here. We want to get X by itself, so I guess first we're going to subtract 1,500. That'll get rid of this and give me 540 equals 1.25X. We divide both sides by 1.25. Goes away, and X is 432. So if they sell if they produce 432 widgets, that will be their cap of 2,040. So you can go both ways with these examples. Let's do a different type of example here. In 1980, the average cost of a pack of cigarettes was $1. In 2000, the average cost was $3. Again, these are averages, right? So let's use the information to estimate the cost of a pack of cigarettes today. Well, I'm looking at this and I'm like, you know what? If 1980 is where we're starting, this is how I'm doing it. I'm saying that X is 0. And that means in 2000, X will be 20 because it's 20 years later. So I've got 0, 1, and I've got 23. So I can find my slope by taking y2 minus y1 over x2 minus x1. That's 2 over 20, which is 0.1. Comes out nicely. Because I did it this way, I have a y-intercept of 1. So I can write y equals 0.1x plus 1. Great. Well, the question says pack of cigarettes today. Well, it's 2000, we don't know what the cost is, but it's 2016. So how many years after 1980 is 2016? And the answer is 36 years. So, oh gosh, I made a huge mistake there. I should have made that y. Okay, sorry about that. So we take 36 and we plug it in for x. So y equals 0.1 times 36 plus 1. Multiply here, I get 3.6 plus 1. So the average cost of a pack of cigarettes today is $4.60. I don't know if that's true or not. I don't smoke, but I feel like they're more expensive than that when I hear people talking about it, but I could be wrong. All right, let's talk about number 3. There's a linear relationship between degrees Fahrenheit and degrees Celsius. For water, the freezing point is 30 degrees Fahrenheit, 0 degrees Celsius, and the boiling point is 212 degrees Fahrenheit and 100 degrees Celsius. Write the freezing point of water as the ordered pair. So we're talking about freezing point. Here's the freezing point. Celsius first. So 0, 32. Then it says boiling point. Well, here's the boiling point. Celsius first, so 100 to 12. So now we have 2 points that we can play with. Let's use those values to find the slope. Okay, so again, we have 0, 32, and 100 to 12. So y2 minus y1 over x2 minus x1. That gives me 180 over 100. If I just reduce it, I get 18 over 10. They're both even. I get 9/5. And I'm leaving it like that on purpose. We also know the y-intercept is 32 because we had the point 032. So my model, y equals 9/5 x plus 32. And I left it like that because hopefully you're like, hey, we've used this before when we did temperature conversions a couple sections ago. Yes, you would be right. Because there's a linear model, right, we can use those formulas. Now let's draw the graphical representation. When it's 0 degrees Celsius, which is on this spot, it's 32 degrees Fahrenheit. And when it's 100, it's 212. So if we would connect those dots, and I guess it would continue on, things can get hotter than that. There is your graphical representation of the linear model between freezing point and boiling point of water. Well, temperature of water, really, in degrees Celsius and Fahrenheit.